Now we're going to talk about functions of compound interest, and you can take your time reading all of this, but I'm just going to show you the most important formula on here, which is really at this point one of the few formulas you have to remember is this one. This is called the compound interest formula, and of all the things we've ever taught you in this class, this is actually one of the most useful ones, because this is essentially how you figure out interest rates on everything from a car to a house to your college loan. Okay. Now on this one I'm not going to read it for you, but notice that P is the principal amount is what we call, and normally that's your starting amount. Okay. R is the interest rate, and you have to write that as a decimal, meaning if you have 5%, for example, you're going to have to write that as 0.05, etc. And then the one that gives most people trouble, but hopefully not too much, is N, which is the number of compounds per year, and T is time. All right, so let me just jump straight to a problem so make sure you know what I'm trying to say here. So on this one right here, it says if you take a car loan of $25,000 with an interest rate of 6.5% compounded quarterly. All right, so quarterly means the N is 4 because you're splitting those interest rates in 4s, essentially. It says no payments are required for the first 5 years. 5 years. What will your balance be at the end of those 5 years? Okay, so I would always say, and it kind of tells you the same thing, we're not going to do quite that much work because we have a calculator. But what you need to do is you need to write what you have and then write what you don't have. All right, so P is what I started with, so this is 25,000. R is going to be this number written as a decimal point, so 0.065. And then we have, let's see, N is 4, T is 5 years, and then now we want to know how much money we end up with, so that's A. A is the final amount. Okay, so after that we're really just going to use this formula right here and plug it all in and see what we get. Okay, so we have A is equal to 25,000. 1 plus 0.065 divided by 4 to the power of 4 times 5. Okay, so notice that N is 4, T is 5, right? 5 is the years, 4 is how many times per year you compounded the interest. Okay, so now, especially since we have a calculator like this, instead of doing all this work that it talks about, evaluate the exponents, multiply exponents, let's not do that. All right, let's just plug it all in the calculator exactly like you see it. So we have 25,000, okay, not 2,500, 25,000, and then we're going to write 1 plus, remember to write a fraction, you press alpha y equal. And then we have 0.065 over 4. And yeah, up here you can put it to the power of 20 or 4 times 5. It doesn't matter as long as you do it right. Okay, so in this case I'm going to end up with 34,000. And by that I mean he's going to owe, or I'm going to owe, I guess in this case. On a $25,000 car after 5 years, I would owe $34,510.49. Okay, so that's essentially all you have to do with that. So let's go ahead and move on to example 2. This one is similar, all right, and I'm going to write the formula here one more time so you'll remember it. So I'm going to go up here, write this formula. So we have A is equal to P1 plus R over N to the NT. Alright, let me check that real fast, make sure I did put that on there right, and I did. So there's the formula one more time, right? So now let's talk about what principal. Alright, so actually I don't have P, that's what I'm looking for. And then we have what principal will amount to $3,000. So A is actually 3,000 this time. And R is 0.065, that's the rate. And it says it's compounded weekly, so you just have to know how many weeks there are in a year, and there are 52 weeks in a year. Right? So we have N is 52, so that's how many times we compounded the interest, and this is in 4 years, so T is 4. Okay. let's see, I think we have everything we need. Now we're going to plug it all in. So we have 3,000. It's equal to P1 plus 0.065 over 52 to the power of 52 times 4. Okay, so even though that looks really super difficult, here's the only thing you need to understand, that all of this is just one weird, crazy number. Alright, so all of this is just a number. So if I plug that in my calculator, alright, if I plug just that part in my calculator, that would basically give me halfway there. So again, I would have all of this. If there's anything on this calculator that you don't know how to use, please let me know, and I can definitely help you. Let's see. Okay. So this is what I get. I get 1.2967, around that much. Okay, so we have, let's see, 3,000 is equal to 1.2967. I'm going to leave it at 2p. All right, I rounded a little bit. Now, all of this, remember, all of that number was all of this number. Well, that becomes a very simple problem, hopefully, right? All you have to do is divide both sides by 1.29672. And I'll spare you me plugging in numbers on a calculator, but when you do, you get the principal would be 2,313 and 53 cents. Now, what that means is I have to invest that much money, okay, to have $3,000 by the end of 4 years. Okay, so that's it for that one. If we go to example 3, we have the same idea. Okay, I'm actually not even going to do that. I'm just going to tell you that if you do, well, I'm just going to write the formula. And again, I'll leave it up to you if you want to read it, but it's the same idea. We're looking for what's the balance after 7 years if the interest rate is 3%. Okay, 12 times 7, and you get 4,933.42. Now, I will at least show you how to plug in the calculator, because the next question is exactly the same question, but only like one thing changes, right? So, for your sake, if you're trying to save yourself some time, type it all in like this, and you do have a few problems on the homework where very little changes in this formula. Okay, notice that this is being compounded monthly, all right, so there's 12 months in a year, that's where the 12 came from. Compounded monthly, so up here. And then we have to the power of 12 times 7. Okay, so that's how I got that number. Okay? Now, if you go to the back of this, alright, they have exactly the same problem. Alright, exactly the same problem, except for now, they're compounding this interest daily. And since there's 365 days in a year, that's why I came up with this number, okay? And then we have 365 times 7, okay? So remember that, all of that, so if you're looking at this, you're going, oh my God, I don't know where that came from. Remember, all of this came from this formula. Okay, so the only thing I wanted to show you that is that if you do have several problems that are exactly the same, you just have to change a few things. Just scroll up, alright, press enter, and then change what you need. In this case, I'm going to change this to 365 times 7, and I'm going to come over here, and I'm going to change that 12 to 365, okay? So that way it saves you some time, you can do it faster. We got 4,934 and 67 cents. So 4,034.67. Now, if you did all the math for a bunch of these, right, and this is the one with the, let's see, we did daily and we did monthly, right? Notice that even though you think it would make a huge difference, it doesn't make a ton of difference if you compound the interest either annually. I mean, for example, just look at annual and daily, all right? The difference is only about a little bit less than $20, okay, between those two. So the difference between those is not very much, okay? So now we're going to go ahead and talk about something called continuously compounded interest, all right? And they have a different formula that actually came from that formula up there that I showed you. But now we have this formula. So anytime you hear the word compounded continuously, meaning all the time, is just continuing, all right, to be compounded all the time. So if you hear again the key word compounded continuously, then you're going to use this formula. A is equal to P, which is the principal, E, which is Euler's number, or base E, which we did in last section. R is the rate as a written as a decimal. Okay, and then T is years. All right, so let's go ahead and talk about how to use this. And it turns out to be pretty simple. But all right, on this one right here, we have the same type of problem, but now notice that it says compounded continuously. So we're going to use a different formula. We're going to use A is equal to PE to the power of RT. Okay. So if we do this, we're going to use this formula because it says that we're going to compound this continuously. Anyway, so let's go ahead and write this out. So we have if 4,000 is invested, so we don't know what A is. What is the balance after 7 years? So this is the balance after 7 years. The principal will be 4,000. That's how much money you started with. R is 3%, which is written as 0.03. Compound continuously, we already talked about that. That just tells me that I have to use this formula. And T is going to be 7. Okay, so now we're going to plug it all in. So we have A is equal to 4,000. E to the power of 0.03 times 7. Okay? And really, after that, all we do is just plug in the calculator. Now, even though on the last video I did tell you what the number was, this letter, okay, this is how you do it. Alright, so we have 4,000. Now again, E, that letter E is either right here or right here. It doesn't matter which one you use, but this one will just put it as a power and this one won't. But I prefer this one right here, so we're going to press the button second. ln, which is natural log, so again second and that should give us that right there. Alright, so now we're just going to type it in exactly like we see it. Okay, so we get 4,934.71. So A is equal to 4,934.71. Alright, so that's it for that solution. Okay, and that is it right here. Yeah, you can do a lot of things. You can multiply that 7 and that 0.03 if you like. Knock yourself out. Alright, finally on example 6. Again, here's the key word. If you see this compounded continuously, you're going to use this formula. A is equal to PE to the RT. Some people call it PERT. You can call it whatever you want as long as you remember it and you know how to use it. Alright, so if you invest that much, which is the principal, an account paying 12% interest, so R is 0.12. Compounded continuously, we know that. Just tells me to use this formula for 100 years. So N, well actually not N, excuse me, T is 100. And let's see, and that is all you have to leave your children as an inheritance. What will be the balance that they will receive? By the way, if you're getting 12% interest on anything back, it's probably illegal. There's almost nothing out there that would give you that much back. But anyway, so all we're going to have to do is plug all this in. So we have A is equal to 6.16 E to the power of 0.12 times 100. Or you can just write this as E to the 12. It doesn't matter. It doesn't matter if you want to do some of the arithmetic. But nonetheless, at some point you're going to have to use the calculator. So nonetheless, the answer that they give you is this. Okay, so it's over $1 million you would get back, okay, if you did that. Hooray. Nothing's ever going to give you 12% interest. But regardless, hopefully this wasn't too bad. I feel this is easier than the last section, but we'll just have to wait and see.